A geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous term by a fixed, non-zero number called the common ratio r. The nth term of a geometric sequence can be expressed directly as the first term times r to the power of n. It can also be defined recursively, where the initial term a0 is equal to a. Consider the sum from the 0th term to the nth term of a geometric sequence. To derive a formula for this summation, we can write out the terms. If we multiply each term by the common ratio r to obtain a new summation, then we notice that we can line up the matching terms. With these terms matching up, we can subtract r times Sn from Sn to obtain 1 minus r times Sn is equal to a minus a times r to the power n plus 1. Dividing both sides of the equation by 1 minus r gives the formula for the summation. Now consider a more complicated summation, where the kth term is multiplied by k. We can use the same method to derive the formula. First, we list out the terms of the summation. Then we multiply the summation by r to obtain a new summation and line up the terms by matching exponents. Notice that the coefficients of aligned terms differ by 1 when subtracting r times Sn from Sn, and the term 0 times r to the power of 0 is simply 0. Hence, 1 minus r times Sn is equal to the sum from k equals 1 to n of r to the power of k minus n times r to the power of n plus 1. From here, we can apply the previous formula we derived by factoring out an r from the summation so that the index of the summation starts at 0 instead of 1. Then it just takes a few more steps of simplifying to obtain the formula for this summation. We can also derive this formula using calculus. This finite geometric series can be viewed as a function of r. If we take the derivative of it with respect to r, then we obtain a summation that only differs from the summation we are interested in by a factor of r. We already know the formula for a finite geometric series. Hence, we can apply the quotient rule to derive the formula for this summation. We can simplify this expression, and the last step is to multiply everything by r. Finally, consider a summation where the kth term is equal to the product of the kth term from an arithmetic sequence and the kth term from a geometric sequence. After splitting this into two summations, we can directly apply the two formulas that we derived. This gives us the formula for a finite arithmetic geometric series.